But of course, sort of our last topic here is in addition to using stress and strain to remove material in subtractive manufacturing, what we're continuing to see more of is the opposite of subtractive manufacturing, where you start with lots of material and then you whittle away, or you remove the stuff you don't want. In additive manufacturing, you start with nothing and you only add those things that you do want. Okay, so here happens to be a little YouTube. We've all seen additive manufacturing, and we call it one version of that is called 3D printing. Take a look at this video real quick and see what we're going to get into this semester. As soon as I get it to work, here we go. Fabulous.
.3D printing has been around for almost 25 years now. But for a long time it was used for engineers and by engineers for prototyping new products that they would then mass produce. What we did in 2007 is we realized basically that, hey, why don't we use this amazing technology to give anyone access to manufacturing? Why don't we use this technology, these 3D printers, to make actual final products?
It's a rapid prototyping technology. The same way that you might carve something out of wax or make a little sculpture, glue a bunch of matchsticks together and make a castle, is the same way now you might sit down at your computer and use a CAD program like Rhino or Maya to sculpt something and then print it out. So for me, 3D printing was a way to bring together art and science. Like, I was able to express the artistic thing that I could see in my head, but use really precise techniques and technology to realize that.
You know, if you understand 3D printing to mean the deposition and or fusing of material by layer, it really opens up what you could consider 3D printing to be. I think the most interesting advancements in terms of where 3D printing is and is going have to do with dimensionality and materials. So both at the small scale of dimensions and the large scale. Like, people are getting parts scanned in their body to get custom implants made for, like, if they're having heart troubles and things like that. Or at the very, very big scale, like the large gantry mounted kind of building scale applications. I think those are really interesting. And then shifting out of plastics into things like ceramics, like other biological materials that people are looking at printing in. Really, that opens up what 3D printing is and what its applications can be in a kind of exponential rate in terms of where it would go and what you would do with it.
It's a good time for experimentation. It's a good time to think about how something that's as old as the clothing industry could be redefined with new technologies. We use digital fabrication technologies and software techniques to invent what fashion design means for a digital age. Artists are always the early adopters. We essentially want to be the first fashion label that's software. We started working with 3D printing because we like this idea of, like, could we make clothing without sewing? Having one machine that can make really impossible shapes is a huge benefit. So this is a 3D printed bikini. So designing the bikini was really about designing this generative textile, like designing a way for 3D printed to be almost like fabric and be flexible and fit to the body. And so how this is done is, after we modeled this 3D shape, it actually fills the surface that you want with this geometry that creates this fabric-like structure. It packs the circles closer and smaller at the edges, and then towards the middle sections you have bigger circles. And this is nice because it actually like looks interesting for a bikini, and it's aesthetic as well as functional. So we've done some work with 3D printing. We felt that people really understood shoes. So our goal is to actually have like a dedicated shoe printer in a store, and then people could like print their shoes. Or you could even have like basically a printer you would buy just to be able to make yourself as many shoes as you want.
Inspiration, I think, is one of the things that most people need to really get started, especially with new technology. So now what we've therefore created are creators, and our co-creation platform is where you can adapt in a very fun and easy way existing designs. So Shapeways, we built the basic platform to enable people to upload and print the designs they care for. You can share it with your friends. You can even open a shop, and you can start selling your new invention, your new creative idea, to a worldwide audience.
Like, the one thing that's really interesting about this technology is that it's more accessible. Because it's more accessible, it's not only the hardware is more accessible, it's also the language that it's been coded in is more accessible. Also, the learning resources that you need to be able to do it yourself is also more accessible. Right? So now all of a sudden, the big walls that existed before in terms of who had the privilege of being able to create what and largely dictate how people used it are gone. But again, I mean, I think it just goes down to the fact that, you know, information is everywhere now. Everyone has access to it, and it's very easy to do whatever you want with it. The technology that exists today, it also shapes the way that you think about what the possibilities of tomorrow might be. You know, so if you have a great idea, that idea might not be ready to come into the world yet until there's a mechanism put in place, right, that makes that idea now realizable.
People are comparing the 3D printing revolution to the revolution that happened with personal computing. I don't necessarily think there'll be a 3D printer in every home, but I think there'll be a 3D printed product in every home. There'll be an application for it for everyone.
Push a button here. There's different ways to do our 3D printing. There's the sort of the drop by drop, and then there's the powder form, which we just saw, and definitely different ways to use this material to do other things. So what I hoped to accomplish in this particular Prezi was to specifically introduce you guys to how this material, how we can use material and use pushes and pulls on the material, especially to shape it or turn it into something that we'd like to do. In the case of pushing or pulling something to the extreme, where we actually deform it, we can reshape it and then harden it, sort of like a clay form. Or sometimes pushes and pulls can be a bad thing, like the Tacoma Narrows Bridge, where it tears it apart. Or we can use stress and strain on purpose, like a jackhammer or those giant steel cutting jaws, to tear things down and destroy things. The CNC lathe, the computer numerical control lathe, is definitely something that we use in manufacturing now to make lots and lots of parts. But increasingly, as the prices fall, we're starting to shift over to additive manufacturing with what we're calling 3D printing, and that's what we're going to be talking about even more of here inside this course. You'll notice from the last video, they mentioned that 3D printing was important, but so was materials. New materials that the 3D printers are going to be printing, and how do they respond once they're built like that. So with that, I think we've walked through this presentation, and we're going to keep on rolling. Welcome to Stress and Strain, and we'll keep on going. All right. Thank you much. Talk to you soon.